Hi guys, welcome to another episode of MrLopezClasses.com. This is the chapter 5, episode 3, and this video is related with the valve lash calibration and engine compression test. We are going to verify if our combustion chamber is properly sealed, if we don't have leaks, if we don't have any small leak on the valves or on the rings or on the gasket, the head gasket, if the compression chamber is properly sealed. The compression of the engine depends if the rings are properly installed, the valves close properly, the head is properly torqued, the head is in good condition. All of those are factors that affect the engine compression. And also we are going to calibrate the valves. We are going to use the caliper in order to calibrate the lash in between the head of the valve and the rocker arm. We are going to do that valve calibration, and this is very important in order to keep the engine running in perfect condition. Let me explain why the valve lash calibration is critical. It's very critical, especially in diesel marine engines. You remember, we are going to refresh quickly the cycle of the 4-stroke cycle. You remember during the intake what happened with the piston? The piston is going down. What valve is closed during the intake? Intake valve is closed, the piston goes down, and exhaust valve stay closed. And right now the piston goes up and both valves close. And now the explosion, the piston goes down and the valves continue closed. And finally the piston goes up again and the exhaust valve is open. This is the cycle. Okay, suppose that during the intake valve open, but for some reason the exhaust valve open a little more. A little. The exhaust valve during the intake should be completely closed. What happens if during the intake the exhaust valve open a little? This is good? No, it's not good. It's not good. Especially in marine engines, it's not good. What happened with the exhaust manifold in a marine engine? The exhaust manifold is in the same element together with the heat exchanger. At the end of the exhaust manifold, as you see on the picture that you have on the screen right now, at the end of the exhaust manifold, in the elbow of the exhaust manifold, the gases coming out through the exhaust manifolds are mixed with the salt water. In that specific point, you have smoke and salt water. What happens if during the intake the exhaust valve should be closed? What happens if during the intake one or two exhaust valves open a little? How much is the suction pressure when the piston is going down in a diesel engine with good seal? The suction pressure is a big suction pressure, negative pressure, suction. That excessive suction pressure suctions salt water, and the salt water enter in the combustion chamber. Catastrophic. Yes, my friend, this is one of the reasons for intrusion of salt water in the combustion chamber is during the cranking, when the pistons are going down and for some reasons the exhaust valves are not properly calibrated. One valve or two valves open a little during the intake and the salt water enter in the combustion chamber. Finito. The engine is completely destroyed. The engine is completely destroyed. What is the problem? The water entering in the combustion chamber, and you know what happened when salt water entered in the combustion chamber? Yeah, the expansion, the thermal expansion of the aluminum is twice than the thermal expansion of the iron. The piston expand and block the engine immediately. This is catastrophic. This is the enemy of the diesel engine. This is one of the possibilities for intrusion of salt water in the combustion chamber. Later, I'm going to explain the second possibility. But this is the most common. It's during the cranking. For that reason, what is the recommendation in a typical marine diesel engine? You crank the engine one time, maximum 2 times. If the engine no start, no continue cranking, because it's possible that you suck some water. You need to verify why the engine no start at the first attempt. If not, it's possible that the engine suction water. Okay, for that reason, it's critical in a diesel engine keep the valves properly calibrated. Keep the gap in between the valve and the rocker arm appropriated according with the manufacturer specifications. We are going to do that procedure. We are going to calibrate that gap. So we are going to check this picture. In this picture, we have the valve. We have the rocker arm. This is the rocker arm. And this is the gap. This is the gap that we are going to calibrate with the feeler gauge. The calibration that you have in this moment on the screen, we are going to do this calibration right now. Okay, right now it's clear for you that the valves should be properly calibrated. Yeah, all right. What happens if the intake valves open too much during the intake? Or open no the amount necessary, open a little. When the piston is going down, not enough amount of air enter in the combustion chamber, and at the end of the cycle the mixture will be rich and you have black smoke. We are going to talk later about that. For that reason, the calibration of the valves are critical. We are going to do that process. I am going to explain my procedure that you can follow for any type of engines. Of course, the first recommendation is if you have the manual and you have the procedure to calibrate the valves according with the manufacturer specification, follow the manual, follow the guide. This is the most important part. ABYC question. Always follow manufacturer recommendation. That's very important. But in some cases, you are in the middle of the ocean, you don't have the manual, you don't have internet, you don't have access to the manual, you can follow my recommendation in order to calibrate the valves, the Lash valve calibration, and you can solve the problem easily. Okay? I am going to explain right now what is the process to calibrate the valves appropriated. All right? And yes, and also in the second part of the video, we are going to use the compression tester. We are going to remove the injector, and we are going to introduce the compression tester in order to verify if the compression internally in the combustion chamber is the compression recommended for the manufacturer. Each manufacturer have your own compression recommended. Yeah, and for that reason we are going to use the appropriate tools in order to do that procedure properly. All right, my friends? Okay, we are going to start with the process to calibrate the valve Lash calibration. The most important part when you try to do valve Lash calibrations is bring the cylinder number 1 to top the center. Let me I tell to you something. We are going to study in the next chapter the procedure to put the engine on time, the procedure to calibrate the timing of the engine. What is the meaning of that? You remember I explained to you that the injector should be open just a little before the piston reach the top of the center. In that moment, the injector open, spray the fuel liquid in the combustion chamber, and the explosion is produced, and the piston goes down immediately. In order to send the order to the injector to open at that specific moment, you need to put the engine on time. What is the meaning of that? You need that the valves, the intake valves and exhaust valves, open and close exactly in the moment that you need in order to open and close the injector at the precise moment. If not, the engine is not on time. You remember what is the consequence when you have a misfiring? When you have misfiring is when the explosion occurs in other moment. No, in the moment used before the piston reach the top dead center at the end of compression. This is exactly the moment where the explosion should be created. If the explosion is in a different moment, the engine is creating a misfiring, vibrating, explosions, detonations, flame on the exhaust pipe. Those are consequences of a misfiring. Yeah. And if the engine continues running with misfiring, the engine destroyed the motor mounts. The motor mounts are broken, and the engine destroyed in marine applications. The alignment of the engine is right now erratic, and you have excessive vibration, and you can crack the fiberglass of the hull. This is critical in marine engines, especially in diesels, because the torque produced for a diesel engine is a huge number. It's a big torque, and if you have misfiring, the vibration destroys the hull, destroys the stringers, the motor mounts, and you have a catastrophic consequence. For that reason, the valve Lash calibration is important, because the vibration and because the intrusion of salt water in the combustion chamber. Alright? Okay. We are going to study in the next chapter that the procedure to put the engine on time is always with reference to the piston number 1. What is the idea? We are going to put the gear of the crankshaft, the gear of the camshaft, and the gear of the fuel injection pump aligned when the piston number 1 be located at top dead center with both valves closed, no? At the end of the compression stroke. Oh, let me have a question for you. How many times is the piston in top dead center in one complete cycle? When I say cycle, I say about intake, compression, power, and exhaust. In one complete cycle, how many times the piston will be in a top dead center? Let me check. Intake, compression, 1 time, power, and exhaust, 2 times. Yeah, in one complete cycle, 2 times. The piston will be in top 2 times and in bottom 2 times. Ready? Okay. In which time, in which stroke, both valves are closed? Let me check. In compression, both valves are closed. At the end of exhaust, one valve is closed and the exhaust valve is open. No. Only in compression, both valves are closed and the piston is on top. Perfect. This is exactly the moment that you need identify. This is the position that you need locate in the engine in order to calibrate the valves. Why? Because in this moment, when the piston is on top the center with both valves closed, what happens when the valve is closed? The spring is compressed or the spring is extended? When the valve is closed, it's because the spring is extended. Okay. When the spring is compressed, like the picture that you have on the screen, the valve is open. Okay. I am going to calibrate the gap in between the rocker arm and the valve. Okay, the valve should be closed. Then the spring will be extended, and the rocker arm will be free. The rocker arm will be free. If you move with your hand, you can move the rocker arm because the rocker arm is not touching the face of the valve. Alright? In that moment, the rocker arm is free. Okay. If the piston is in top dead center at the end of the compression, both valves are closed, and I can move with my hands both rocker arms. For that reason, in the video, you see that Professor Rodriguez is locating the piston in top dead center, and Professor Lopez is moving with the hands both rocker arms in order to verify that both rocker arms are free. In that moment, this is the end of the compression, and this is exactly the point where we are going to introduce the filler gauge, like the procedure that you see on the screen right now. We are going to introduce the filler gauge in what measurement? What measurement on the filler gauge? The measurement recommended for the manufacturer. Each manufacturer have a different gap recommended per each valve. If you see on the screen, for that particular engine, the recommendation is 0.017 inches per both valves, intake and exhaust. We are going to use the filler gauge. We are going to select 0.017, and now we are going to calibrate the gap of the valve. What is the procedure? I introduce the filler gauge. In this moment, I see that the filler gauge have too much play. In that case, I need to adjust the other end of the rocker arm. In this moment, Professor Rodriguez adjusts with the screwdriver, with a flat screwdriver, that gap. And with the nut, if the filler gauge is moving a little tight, not completely tight, a little tight, in that moment you can tie the nut, and this is exactly the calibration of this rocker arm. And right now we are going to pass to the second valve, the exhaust valve, and we are going to do exactly the same. We are going to introduce the filler gauge, and with the screwdriver we adjust the gap, and with the nut, right now with the nut, we are going to tighten the gap according with the manufacturer specification. This is for piston number 1. Right now we are going to turn again the crankshaft, normally 180 degrees, and we are going to verify if both rocker arms in the second cylinders are free. This is an indication that the piston is in top dead center with both valves open. And now we are going to do the same procedure. We are going to introduce the filler gauge in between the rocker arm and the valve, and we are going to calibrate the gap with the screwdriver. Now we adjust, and after that with the nut we fix it exactly, because the gap is a little tight, not completely tight. You can move it, the filler gauge. This is exactly the position, and now we are going to do the same in the second valve. Exactly, we calibrate the filler gauge, and once again we adjust the bolt and we tie with the nut. Okay, and we are ready to continue the same procedure. We are going to rotate another 180 degrees, and we try to find that the piston number 3 be in the same position with both valves closed, the piston at top dead center, and now we calibrate again and again all the cylinders. My friends, this is the procedure to do the valve lash calibration. Right now you are ready to do that procedure, valve lash calibration. This is a critical. The payment is good. Calibrate the valves in a diesel engine. The payment is excellent. And yes, we are going to practice in the lab that procedure. This is very, very important. What is the most important when you try to do that project? The project to calibrate the gap on the valves. The most important is you have the manual. What manual? You remember? Yes, service manual. Service manual. You have the service manual of the engine. That's the most important part. Okay, I have the service manual. And you identify exactly according with the model of the engine and the series of the engine that this is exactly the engine that you have on the manual. Okay, 100% sure. And now check in the chapter dedicated to valve lash calibration. And what is the valve lash, the gap, the clearance recommended for that engine? Okay, for intake and for exhaust, right now, like the manual that you have on the screen, you adjust, you select the filler gauge appropriated for that gap. And now you do the process that I explained a couple of minutes ago. Alright, this is exactly the procedure for any type of engine. Oh, Mr. Lopez, in my boat, the diesel engines are big diesel engines, and it's impossible with your hand try to move the harmonic balancer in front of the engine in order to rotate the engine, because it's a big engine. Okay, you can disconnect the computer, the harness on the computer, on the ECM, on the ECU. Remove the push button in order to crank the engine slowly, crank, and rotate the engine, slowly in order to select exactly the position top dead center with both valves closed. All right, you have different ways to rotate the engine. You can use the remote start switch, like the remote start switch that you have on the screen right now, and you connect, of course, in between the big terminal of the start motor and the signal. In between those two terminals, you connect the remote control, and you crank until the engine is in the position that you need. It's clear, my friends? This is the procedure to do the valve lash calibration. It's the same procedure used in gasoline engines, and it's the same project for both engines, gas and diesel. This is the procedure to calibrate the valves. Okay, why in the majority of the diesel engines they require calibrate the valves, and why not in my gas engine, in my car? Why not in my car? I don't need to visit the dealer frequently in order to calibrate the valves in my car. It's because of the lifters. Let me show to you in this picture. In this picture we have the lifter. This is the lifter. There are two types of lifters. One lifter is a solid lifter that the lifter that you have on the screen right now is a solid cylindrical piece of steel, and you have another one hydraulic. The hydraulic, like the hydraulic cylinder that you have on the screen right now, those lifters keep the valves, keep the gap. This one, this is the hydraulic lifter. The function of the hydraulic lifter is keep the clearance in between the rocker arm and the valve zero. If your engine have hydraulic lifters, you don't need calibrate valves. The majority of the gasoline engines, they have hydraulic lifters than the lifter that you have on the screen right now. And the majority of the diesel engines, they have a solid pieces of metal or mechanical lifters, and you need calibrate the valves. For that reason, in the majority of the diesel engines, it's necessary calibrate the clearance, the gap in between the rocker arm and the valve periodically. Okay, but there are medium and small diesel engines, some of them with the hydraulic lifters, and you don't need calibrate. For that reason, you need verify the manual and verify if that engine requires valve lash calibration or not. The majority they require, and you need to be familiar with the procedure that I explained before in order to do that calibration. The procedure is not complicated, it's very simple, exactly like I explained. Oh, the same for a big diesel engine or the same for all type of diesel engine. It's exactly the same. The procedure that we did in the video was in a John Deere 5.8 liters, 6 cylinders. This is a very a common diesel engine used in different applications: agricultural, buses, transportation, boats, in generators. It's a very, very, very common engine, 6 cylinders, inline, John Deere. Okay, this is the hydraulic. Let me explain something about this type of lifters. The hydraulic lifter, the lifter that you have on the screen right now, is a cylindrical piece with two pistons. One piston on top and other piston in the bottom here, and one small orifice here. This is the block of the engine, and the galley, the cavity with the oil coming from the oil pump. Suppose that this is the oil pump, and those are the gears of the oil pump. The gears compress the oil and send the oil with high pressure. The high pressure enter here in the middle of the hydraulic lifter, expand the lifter, and here is connected the push rod. When the pressure of the oil is the pressure recommended by the manufacturer, the hydraulic lifter expand and keep. This is the push rod. And keep the push rods against the rocker arm. For that reason, my friends, once again, one of the most important gauge that you need locate appropriated in the console of the boat is the oil pressure gauge and the temperature gauge. Both of them are critical. If you are the captain, you need drive the boat checking both gauge all the time. The coolant temperature and the oil pressure. The oil pressure normally is in between 40 and 60, 70 psi. Each manufacturer have a different number. You need to be familiarized what is the pressure recommended for those engines, and you need run the engines always checking the oil pressure. What happens if the push rods if the push rods are not appropriated extended, is because the lifter is damaged, or the oil pressure on the engine decrease suddenly. And what is the symptom? You have the sound when the valves are the clearance in between the rocker arms and the valve is excessive, and you hear it's basically a sound on the valve cover on the head of the engine. This is normally the sound when the valves are not properly calibrated. You need to verify immediately if you have the oil pressure in the level recommended by the manufacturer. No, the oil pressure is perfect, it's 60 psi, but I hear that the valve don't close. Okay, you need to verify, you need to stop the engine, and you need to calibrate the valves and verify if the calibration, if the gap is too much open in a couple of cylinders. Start the engine again. Oh yeah, right now the problem was solved. Two valves was improperly calibrated. All right, or probably no, the gap is good. You calibrate again the valves. The valves are properly calibrated, but the sound increase. This is probably another problem. Probably the lifter is damaged, or probably the push rod is bended. If the push rod is bended, probably the gap in between the rocker arm and the valve is not appropriated. All right, or probably the lifter is broken, is damaged. Yeah, there are different factors, and you need go step by step to identify the problem is the lifter, the problem is the push rod, or the problem is the oil pressure. For that reason, I recommend in that case, in that procedure, in that diagnosis procedure, use the stethoscope. The stethoscope that you have on the screen right now is an important tool. All right. If you have the stethoscope, with the stethoscope you can identify if the sound is on the valves or if the sound is on the bearings. The knock probably is in the block, or the knock probably is on the head. Normally, when you have a knock, when you have a sound that is different like the regular, normally you have a check engine light. You have a light on the display of the dashboard. If you check the code for that check engine light, you have the code related with knock sensor, knocking sensor, knock sensor. All right, and you need to identify if where is the problem. If the problems are on the bearings, on the crankshaft, or if the problem is on the valves. The majority of the engines, diesel engine, they have two knock sensor. One knock sensor in the bottom of the block for in front of the crankshaft, and other knock sensor on the valves, on the head, in order to identify if there are problems on the valves or problems on the crankshaft. All right, but those are situations that we are going to solve it later in other chapters, and I am going to explain in details what is the procedure to identify those codes and the procedure to clean those codes when you have those codes in the computer in emergency. All right, this is the procedure to calibrate the valves, the valve lash calibration, and right now we are going to do the procedure to do the compression test.